If you look at the graphs of sine and cosine, you will see that they repeat over and over again. When a graph comes back to the same matching point it was before, we can say that it has completed one period. The functions sine and cosine have period 2 pi. So if sine of x plus 2 pi is given to you, it's just sine x. And cosine of x plus 2 pi is given to you, it's just cosine x. You can also see that the graphs oscillate between a high point and a low point over and over again. This oscillation is called the amplitude. So knowing these facts, let's look at the graphs of sine and cosine, starting off with no shifting done. So for a sine or cosine function that has no shifts, their respective equations are y equals a sine kx and y equals a cosine kx, where k is positive. A is in green on both of these, so if you take the absolute value of A, that will give you its amplitude, how high and how low the graph goes. And 2 pi over k is in red for both of these, is the period. So if you take k and plug it in here, 2 pi divided by k will give you the period of sine and cosine. If you're to graph sine or cosine, an appropriate interval to which to graph one completed period is between 0 and 2 pi over k. Doesn't mean it's the only one, but it's appropriate because after all, it repeats over and over again. Simplest is easiest. So let's start off with the function sine. Sine typically starts at 0, goes up to 1, goes down and crosses the x-axis at pi, then goes down to -1, and then back up and crosses at 2 pi, where it will repeat the process over and over again. So that's why we can usually stop at 1 period. Now this is the normal graph of sine, and this has an amplitude of 1 because it goes up to 1 and down to -1. Cosine, on the other hand, starts at 1, will go down and cross the x-axis at pi over 2, then go down as far as -1, then come back up, cross the x-axis at 3 pi over 2, and then go back up to 1 where it hits 2 pi, completing 1 period. So cosine again looks like this. It goes as high as +1 and as low as -1, meaning it has an amplitude of 1. And to graph this would be enough for cosine, because again it just repeats over and over again. So these are sine and cosine graphs. Now those were the unshifted. You can also shift sine and cosine. So for a sine or cosine function that has shifts, their respective equations are y equals a sine k times the quantity x minus b, then plus d, and y equals a cosine k times the quantity x minus b plus d again, where k is positive. Now everything is color-coded to make it a little bit easier for you in these functions. Again, the absolute value of a is the amplitude. That's how high and how low it goes. If you have k outside of the parentheses here, you can just plug it in to 2 pi over k and get its period. If it's not factored out, you need to factor it out. Once it is factored out, you have your b value. And b is the phase shift or horizontal shift, how much it moves either to the left or to the right. And d is the vertical shift. It's the number outside of the trig function. That's how much it moves it up or down. So for these kind of graphs, an appropriate interval on which to graph one completed period is b to b plus 2 pi over k.